In this video, I will show you how to solve trig equations with multiple angles, like this one that has the cosine of 3x instead of just cosine x. For number 5, we will start by isolating the trig function. So adding 1 to both sides, we have 2 cosine 3x is equal to 1. Dividing both sides by 2, we have cosine 3x is equal to 1/2. Next, we solve for 3x by asking ourselves the cosine of what is equal to 1/2. We know that cosine of pi over 3 is equal to 1/2, so pi over 3 is the reference angle. In every quadrant, there is an angle that has a reference angle of pi over 3. The cosine of any of these will give us some kind of 1/2, but 2 of these will be positive 1/2, and 2 of these will give us negative 1/2. Cosine is the x value on the unit circle, so it is positive on the right and negative on the left. In this case, we want cosine of 3x to equal positive 1/2. So we can forget about these two angles. We are only looking for solutions on the interval between 0 and 2 pi. So normally we would stop right here, because these are the only two solutions for 3x between 0 and 2 pi. However, we are not solving for 3x. We're not done. We are solving for x. Because we have to divide by 3 to get x by itself, these values are going to get smaller. So more solutions are going to fit between 0 and 2 pi. How do we find the additional solutions? The key is to add 2 pi. We know that adding 2 pi takes you all the way around the unit circle and back to the position where you started. So that will always give you another solution. Adding 2 pi is the same thing as adding 6 pi over 3. I'm going to think of it this way so we automatically have like denominators. So if I want to take pi over 3 and add 2 pi, I can just do pi over 3 plus 6 pi over 3, which is 7 pi over 3. Similarly, if I want to add 2 pi to 5 pi over 3, I'm going to add 5 pi over 3 plus 6 pi over 3, which is 11 pi over 3. So far we have found 2 sets of solutions. Do we need to find another set? As a rule of thumb, the multiplier tells you how many sets of solutions you need to find. So because we have 3x, we probably will need 3 sets of solutions. So let's find one more pair of solutions by adding 2 pi. In other words, by adding 6 pi over 3 again. 7 pi over 3 plus 6 pi over 3 is 13 pi over 3. Similarly, 11 pi over 3 plus 6 pi over 3 is 17 pi over 3. To get x by itself, we need to divide both sides of the equation by 3. In other words, we need to divide each one of these fractions by 3. But remember, when you divide a fraction by 3, that's the same as multiplying by 3 in the denominator. So for the first value, I'm going to end up with pi over 9. And similarly, all of these values will be over 9 instead of divided by 3. These are all solutions to the original equation. But are they all less than 2 pi? Yes, they are, and we can tell because 2 pi is the same thing as 18 pi over 9. Notice that all of these values are less than 18 pi over 9, so they are all less than 2 pi. Let's try number 6. First, we need to get the trig function by itself. Adding 1 to both sides, we have the square root of 2 sine 2x is equal to 1. Dividing both sides by radical 2, we have sine 2x is equal to 1 over radical 2. Let's start by solving this equation for 2x by asking ourselves the sine of what is equal to 1 over radical 2. By the way, 1 over radical 2 is the same thing as radical 2 over 2. We know that the sine of pi over 4 is equal to 1 over radical 2, or radical 2 over 2. So that tells us that pi over 4 is the reference angle. So here is the reference angle of pi over 4, but every quadrant has an angle with a reference angle of pi over 4. The sine of any of these 4 angles will give us 1 over radical 2, except 2 of these will give us positive 1 over radical 2, and 2 of these will give us negative 1 over radical 2. In this case, we want the sine of 2x to equal positive 1 over radical 2. The sine function is the y value on the unit circle, which is positive in the first and second quadrants. So these are where the solutions will be. So this is our first set of solutions. The 2x tells us that we will probably need 2 sets of solutions. We can find the other set by adding 2 pi to both of these values. In other words, let's add 8 pi over 4. 8 pi over 4 plus 1 pi over 4 is 9 pi over 4. And 3 pi over 4 plus 8 pi over 4 is 11 pi over 4. Finally, we can get x by itself by dividing everything by 2. Remember that dividing pi over 4 by 2 gives you pi over 8. You simply multiply the denominator by 2. Similarly, we get 3 pi over 8, 9 pi over 8, and 11 pi over 8. Notice that 2 pi is equal to 16 pi over 8. So all of these values are between 0 and 16 pi over 8. Also notice that if we try to add 2 pi again, in other words, if we add 8 pi over 4 to 9 pi over 8, we get 17 pi over 8. This is bigger than 2 pi, so we were right to stop at 2 sets of solutions. Number 7 is not a multiple angle problem, so we should be able to solve it pretty easily. Adding 1 to both sides, we have sine squared theta is equal to 1. Taking the square root of both sides gives us sine theta is equal to plus or minus 1. So the sine of what is equal to 1 or negative 1? Sine is the y value on the unit circle, so the sine of pi over 2 is positive 1, and the sine of 3 pi over 2 is negative 1. So that's it for number 7. Number 8, we are back to the multiple angles. Let's start by solving for 3 theta by asking ourselves the sine of what is equal to negative 1. Well, the sine of 3 pi over 2 is equal to negative 1. So that is the first solution for 3 theta anyway. But the fact that we have 3 theta tells us that we will probably need 3 sets of solutions. We can find the other solutions by adding 2 pi. Adding 2 pi is the same as adding 4 pi over 2. 3 pi over 2 plus 4 pi over 2 is 7 pi over 2. We can get the third solution by adding 4 pi over 2 again. 4 pi over 2 plus 7 pi over 2 is 11 pi over 2. To get theta by itself, we need to divide everything by 3. So that will give us theta is equal to, and when we divide a fraction by 3, we multiply the denominator by 3. So this will be 3 pi over 6 and 7 pi over 6 and 11 pi over 6. 3 pi over 6 reduces down to pi over 2. These are the solutions to the original equation between 0 and 2 pi. Notice that 2 pi is the same thing as 12 pi over 6, so all of these values are less than 2 pi. Number 9 is not a multiple angle problem, so let's knock it out quickly. Adding 3 to both sides gives us 4 cosine squared x is equal to 3. Dividing both sides by 4 gives us cosine squared x is equal to 3 over 4. Taking the square root of both sides gives us cosine x is equal to plus or minus the square root of 3 over 4. Taking the square root of a fraction is the same as taking the square root of the numerator and denominator separately. So this is like having the square root of 3 over the square root of 4. But of course the square root of 4 is 2. So we have cosine x is equal to plus or minus radical 3 over 2. So what's the reference angle? The cosine of what is radical 3 over 2? Well, that's pi over 6. So here's our reference angle of pi over 6. But every quadrant has an angle whose reference angle is pi over 6. The cosine of any of those will give you radical 3 over 2. Just 2 of them will be positive and 2 of them will be negative. Since we are looking for the values of x that will cause cosine x to be positive or negative radical 3 over 2, all 4 of these values are solutions. Kabam! Number 10. Let's start by adding 1/2 to both sides of this equation. So we get cosine 2 theta is equal to 1/2. Now we can solve for 2 theta by asking ourselves the cosine of what is equal to 1/2. We know that the cosine of pi over 3 is 1/2, so pi over 3 is the reference angle. So here's the reference angle of pi over 3. But every quadrant has an angle with a reference angle of pi over 3. And the cosine of any of these angles will give us some kind of 1/2. 2 of them will give us a positive 1/2, and 2 of them will give us a negative 1/2. In this case, we want cosine of 2 theta to equal positive 1/2. Cosine is an x value on the unit circle, so it will be positive on the right. So the answers are pi over 3 and 5 pi over 3. At least that's one set of solutions. How many sets of solutions do we need? The 2 theta tells us that we will probably need 2 sets of solutions. We can get the other set of solutions by adding 2 pi. In other words, by adding 6 pi over 3. 1 pi over 3 plus 6 pi over 3 is 7 pi over 3. And 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. To get theta by itself, we need to divide everything by 2. Dividing a fraction by 2 is the same as multiplying by 2 in the denominator. So we will get pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice that 2 pi is the same as 12 pi over 6. So the second pair of solutions that we found are less than 2 pi. Also notice that 11 pi over 6 is very close to 12 pi over 6. So if we tried to add 2 pi again, we would go over 2 pi. This will be the last one. Let's start by adding 1 to both sides. So we get radical 2 sine 2x is equal to 1. Dividing both sides by radical 2, we get sine 2x is equal to 1 over radical 2, which is the same thing as radical 2 over 2 if you're more comfortable with that. We can solve for 2x by asking ourselves the sine of what is equal to 1 over radical 2. We know that the sine of pi over 4 is equal to 1 over radical 2. So pi over 4 is the reference angle. Here are all the angles on the unit circle with a reference angle of pi over 4. The sine of 2 of these will be positive 1 over radical 2, but 2 of these will give us a negative 1 over radical 2. Sine is the y value on the unit circle, so it is positive in these upper two quadrants. So pi over 4 and 3 pi over 4 are the solutions. The 2x tells us that we will probably need two sets of solutions. We can find the other set by adding 2 pi. In other words, by adding 8 pi over 4. 1 pi over 4 plus 8 pi over 4 is 9 pi over 4. And 3 pi over 4 plus 8 pi over 4 is 11 pi over 4. We can get x by itself by dividing everything by 2. Dividing pi over 4 by 2 gives us pi over 8. And similarly, we have 3 pi over 8, 9 pi over 8, and 11 pi over 8. So these are the solutions to the original equation. Notice that 2 pi is equal to 16 pi over 8, so these additional solutions that we found are less than 2 pi. Also notice that if we tried to add 2 pi again by adding 8 pi over 4 to 9 pi over 4, we would get 17 pi over 4. When we divide by 2, that would give us 17 pi over 8, which is bigger than 2 pi. So that's why we stopped here.